Welcome back, students. So in this session we'll be discussing about the fifth program, that is the program to add two 64-bit numbers. Okay, so we have two 64-bit numbers here, that is 0x12, that is one value 1. Okay, that is 0x1234 e6 4 zeros, and 0x43 210010. Okay, so they are saved in R0 and R1 respectively. Okay, so this is one 64-bit number, and another 64-bit number is that is this one, that is 0x123489 400 and 0x43212102. Okay, so they are stored in R2 and R3 respectively. So what we have to do is we have to add R1 and R3. Okay, to add this 4-bit numbers and this 4-bit numbers, and R0 and R2. Okay, so we'll get we'll be adding this 32-bit number and this 32-bit number, and this 32-bit number and this 32-bit number. Okay, so R0 and R3 and R0 and R2. Okay, just like you do your basic mathematical addition, like that. Okay, so the result which you get is this one. We'll just verify it before programming. So we'll put it to the hex mode, and we'll just see what is the answer. So what is the first number? That is 1 2 3 4 8 9 0 0 and 4 3 2 1 0 0 1 0. All right, this is added. So you can see that here it is a 64-bit number. It means what? These all nibbles, there should be 16 bits. Okay, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 and 16. 16 into 4 is 64. Okay, plus the second 64-bit number, that is 1 2 3 4 8 9 0 0 4 3 2 1 2 1 0 2. Okay, so when you hit equal to, you'll get this as the answer, that is 2469 96 F4 0. Some mistake here. Okay, just go through it. Okay, we'll just do the calculation again. 1 2 3 4. Okay, E6 4 0 4 3 2 1 0 0 1 0 plus 1 2 3 4 8 9 0 0 4 3 2 1 2 1 0 2. Okay, enter. So you will get it as 2469 6F40 864 22112. Okay, so this is the answer you get after adding two 64-bit numbers. Okay, so you have this is one 64-bit number, this one other 64-bit number. What we are doing is we are dividing each number by two 32-bit numbers. So the left most 16-bit number 32-bit numbers we are adding first, that is by saving into R1 and R3, and by saving into the next left 32-bit numbers, we are saving that into R0 and R2, and we are adding it, and then we are storing the result of two 32-bit numbers as in R4 and R5 respectively. See, because the register can hold only 32-bit number, and the result which we are getting in is 64-bit number, we are saving this 64-bit result as two 32-bit result, that is one in R4, one 32-bit number in R4 and one 32-bit number in R5. All right, so this is quite simple plain program. Okay, wherein you are saving R0 as the first number, okay, and R1 as the second part of the first number. So this R2 as the first part of the second number, and R3 as the second part of the first number. Okay, so next you add R1 and R3 and store the result in R4, and you add with carry. See, when you add these two numbers, that is this number and this number, when you add these two numbers, you may end up getting a carry. Okay, so this numbers, when you add these two numbers, okay, you have to add it with the carry which is generated by these two numbers, addition of the first 32 16-bit numbers. Okay, so that is accomplished by this instruction, that is ADC. Okay, so that you with addition with carry, what R0 and R2, this is R0 and this is R2. Okay, so when you add it with the carry generated by R1 and R3, okay, you get the result is got in R5. Okay, this is the end of the program. We'll just copy this and paste and execute this and check whether we get the answer correctly. Okay, go to project, new microvision project, exp5, enter, choose NXP, yeah. Hit OK, say no, and go to file, new, copy and paste this, export is not required, go to save it as exp5.asm, save it, go to target, right click here, add files to group, search for ASM files, you'll get a list of numbers with number of files with .asm extension. Choose the one which you have saved with the exp5, add it, close it, you'll just get a drop down, hit the drop down and you'll find a file with .asm extension, translate it, find if there are any errors, check if there are any errors, no errors, go to the next step of building and then rebuilding. Okay, go to debug and start or stop debug session. Before that you have to before running you have to enter a breakpoint at the first no operation instruction. So go to debug and insert a breakpoint. Okay, now you can save it and you can run it stepwise by hitting this step icon, or you can directly run all at once. Okay, so you have this 64-bit number saved in R0 and R0 and R1. Okay, 64-bit numbers, that is one 32-bit number and another 32-bit number. Together they make one 62-bit number, and R2 and R3 are another 32-bit number. Okay, a 32 and 32-bit number, that is 64-bit number. So R0 and R1 make up one 32-bit number, and R2 and R3 make up another 64-bit number. Okay, so when you add up these two, okay, you'll get a 64-bit value. Okay, and that 64-bit value is this one. Okay, but how you are adding, that is very important. You are adding R1 and R3 and R0 and R2. Okay, just let me give you a okay, here So this is how is the addition done. R0 and R1, the first 64-bit number, R2 and R3, second 64-bit number. So first you take this one, that is R1 and R3, okay, and then this is added, okay. So R1 and R3 is this one, okay, this is added with this one, okay, that is R0, this R, see here, R1 and R3 are both added and the result is stored in R4, and then R0 and R2 are added, R0 and R2 are added, okay. So and the result, that is the final result, that is stored in R5. Alright, so that's it for that concludes the fifth experiment, okay. So the next experiment is the square of a number. I'll just go through the theory part of this, okay. The execution is quite the same, okay. So what happens here is you have to find out the square of a given number, the squares of the numbers, okay. That is from, you have to create a lookup table, okay, and this lookup tables you may store depending on your requirement, the squares of how many numbers you want, that many numbers squares you have to create a lookup table. That means if you want the square roots from squares from 1 to 10, then from 1 to 10 what are the squares, those squares numbers you have to prepare a lookup table. That is 1 square is 1, 4 square is that is square of 2 is 4, square of 3 is 9, 4 is 16, like that till 10 lookup table is prepared, and it is saved in particular addresses beginning from this address, okay, and this address is labeled as table 1, okay. This is the first thing which you have to keep in mind, that the squares of the numbers of which we have to find are present in a lookup table whose address we have to give to the register, okay. Now this is all the thing which you have already learned, okay. So LDR, load register R0 with the table 1, that is the lookup table address, okay. Once you load that, you have to load the register with the required numbers whose square is required, okay. So we have to find out the square of 4, so load that 4 into the register R1, okay. Next you have to move, you have to left shift it by 2 position, and that is you have to left shift the required number 2 times, and you have to store it into the R1 register, all right. And then what this will do, it is generating the address corresponding to the square of the given number, okay. And then you have to add it to the R0, okay. Okay, that is the load address element, load address of element in the lookup table, okay. Once you add load the address of the element in the lookup table, that means this, that is what we have to find. We have to find the square of 4, right? The square of 4 is 16. That means this address will be stored in R0, okay. This R0 again, it will be that is load register, this address will be stored here, and what is the content of this bracket indicates the content. So this content is what, 16, okay. So this is 16, that is the content is stored in R3. So the result you will find it in R3. We'll just execute it quickly, okay. It will, so that it will give you the clear picture, okay. Go to project. First we have to stop this, okay. Go to project, new microvision project, exp6.asm, sorry, this is a project which we have to create. Okay, so next go to NXP LPC 2148. Hit OK. No. Target. Right click. Sorry, we have to create a file. Okay, so copy and paste this. Export is not required, just delete that. Align this. Okay, save it as exp6.asm. Enter. Right click, add files to group source. Okay, find files with .asm extension and exp5.asm, add and close. Okay, find if the file is present here. Next you go to debug, start the debug session, hit OK for this warning. Oh my god, there's some problem. Okay, we'll just do it once again. This is done .asm. Okay, so we have to find remove this. We have loaded 5 instead of 6. Okay, fine. There are no errors. Start the debug session. Okay, let's run it and stop. Okay, we had to enter the breakpoint here. Okay, debug and insert a breakpoint. Alright, so save this and run it. Okay, so the result should be present in R3. Okay, so just check what is R3. Load the address, the square of number in R3 should be 16. There's some issue, we'll just reset it. Alright, so you are getting the result as R3 as 10. Okay, you can see that. We'll just reset it again and run it. Okay, you see that the result is R3 is 10. Okay, so this concludes the 6th experiment. Okay, so in the next class we'll discuss the remaining experiment. Okay, thank you.